In this example, we're going to look at, relating the application, this idea of what a derivative means, to a graph that, makes sense to us in reality. Okay, so one thing that we're starting to understand is that a derivative represents a rate of change. And what we know from algebra coming into calculus is that rate of change is slope. So the derivative is telling us information about the slope of the graph. So for this example, we're going to consider the effectiveness of a drug. All right, so in the hospital, when you're in pain, if you're sick, they're like on a scale from 1 to 10. In this case, it's a scale from 1 to 0. The effectiveness, E, of some pain-killing drug T hours after it's entered the bloodstream is displayed in this accompanying figure. So right here, T equals 0, we're given the drug, it's been administered, and so the effectiveness is going up, it reaches a certain value, and then the effectiveness starts to decline around 5 hours. And so one thing we want to think about, like if you have a headache and you take Tylenol or some other medicine, to alleviate your pain, it normally says take every 4 to 6 hours as needed. So we take the medicine, our headache starts to go away, but then the medicine wears off and the headache comes back and we have to take it again. So that's kind of what this graph is illustrating. On the x-axis, we have time, and then on the y-activeness, we have effectiveness, meaning we're going from 0 effectiveness down here at the bottom up to full effectiveness, represented by 1. All right, so let's look at part A of this question. At what time does the effectiveness appear to be increasing? And then what is true about the derivatives during that time? So if we're looking at this and we're thinking, well, between 0 all the way until we reach this top point right there, that maximum, it appears that the effectiveness is rising. And so if the derivative is slope, then that might indicate that the effectiveness has a positive slope, or it is increasing, right? So the main idea here is essentially, we're going to say from 0 to 3, on that interval, we have a positive slope. The effectiveness is increasing, okay? So a positive slope, that's also going to indicate the output for the derivative anywhere on that interval from t equals 0 to t equals 3 is again going to be a positive output. All right, so then part B here says, at what time do we estimate, and we're pulling this off of the graph, do we estimate that the drug reaches its max effectiveness? And I've already said that word maximum. The maximum is occurring at t equals 3, we have a max value. All right, so what I might say for maximum effectiveness, let me get a pen here. Maximum effectiveness, and I think you guys can agree with me, that's going to be at t equals 3, right, in here. Okay, so then the next part of the question says, what is true about the derivative at that time? Well, when we think about the derivative is the rate of change, and the rate of change is the slope. So what might we say about the rate of change or the slope at the moment when t equals 3? And so hopefully you guys are all intuiting with me that we would have a horizontal tangent line, and a horizontal tangent line will mean the derivative, I'll say e prime, that derivative is going to equal 0 because the slope of a horizontal line is 0. all right? And we have one last piece here. What is true about the derivative as time increases, so that's going this way on the x-axis, in just the 1 hour before that estimated time of t equals 3. So right in this window, as time increases from 2 to 3, what is happening to that derivative? All right, 1 hour before, as time is increasing. So if we're just zoomed in right on this one little moment. So all of the derivatives, right, let's say the derivatives are positive, and a positive derivative, what we're starting to intuit, means increasing. All the derivatives are positive, they are increasing. But if I were to zoom in, I think I can do that here. Let's zoom in right there, right? If we zoom in on just this little moment in time, so here we have a positive slope, but this positive slope, or let me let that go away, or this positive slope, the slope is decreasing towards 0. So we have positive slopes, but they are getting smaller and they are approaching 0. Right? So what I'll say here is in this 1 hour from 2 to 3, the increasing slope, the derivative, the positive derivative, if you will, is decreasing toward 0. Okay, so that's what's happening there. So even though we still have positive derivatives everywhere over here between t equals 0 to t equals 3, that derivative is shrinking in value towards 0. And then, if we extend on this problem, what's happening between t equals 3 to t equals 5 hours? Well, when we think about all of those slopes, those would be negative slopes. The graph is decreasing, so we would have a negative derivative, and that's a increasing negative derivative. So we would think about that, it's going from like negative 0.1, here we might have negative 1, down here we have negative 2. So the main idea of this kind of application problem, it's really just conceptual and thought process. We're just trying to think about, what does the derivative mean, and how can we use the derivative to interpret, real life situations? Because, Calculus 1, learning about the derivative, that's really when we get to start applying all of these fun algebraic techniques and manipulation techniques that we've been learning for the past few semesters. And now we understand that, and we're getting some real life application that will extend into future math classes. As always, please feel free to email me or leave me a comment if you have any questions or concerns.